How? By looking at a century-old idea, in the 1920s, where an equation pivoted the direction of astronomy. In the 1900s, we have wrongly estimated the age of the universe. It was believed that the universe was static, neither expanding nor contracting. But Edwin Hubble changed everything. He discovered that actually, galaxies in space were moving away from us. And shockingly, there was a pattern in this occurring. The farther the galaxy from us, the more it was moving away. V is directly proportional to d. Where v is the galaxy's recessional velocity and d is distance to that galaxy. This led to the birth of the most disputed numbers of astronomy. Welcome to Lab 360, because together, we will explore the Hubble constant. This was the variable which explained the speed the universe was expanding. At some point of time, all the galaxies in the universe were close to each other before drifting away. If we track back the origins of the universe, we will reach a point in time where all matter and radiation must have been collected at a single spot in space, known to everyone as the Big Bang. And the term, Hubble time, was born, giving us a timescale corresponding to the expansion of the universe. In simpler words, the age of the universe. When calculated, the Hubble constant gives the estimation of 13.8 billion years. Hubble also gave us redshift, the stretching of light. When a distant celestial object releases light, this light, when traveling through the universe, gets stretched, pushing the light to the red end of the light spectrum. So, the redder the light, the farther the galaxy. This led to the establishment of the Lambda cold dark matter model, or in short LCDM. The model which is widely accepted in the scientific community. But, there was another. Fritz Zwicky, a Swiss astronomer, who was one of the first greatest minds of his time. He was the one who brought to attention the existence of neutron stars and dark matter. And if that wasn't enough, he was the pioneer in the study of cosmic rays and supernovas. And he was the one who didn't agree with the interpretation of red light done by Hubble. And he came up with a different theory. The tired light model. As per Zwicky, light photons lose energy when they collide with other particles whilst traveling to us, pushing them toward the red end of the spectrum. This model was not dependent on the Big Bang. But then, in 1948, on the 1st of April, the Alpha Beta Gamma paper published an article in support of the Big Bang theory with strong evidence. The paper clearly demonstrated that elements like helium, hydrogen and other heavy elements were developed during the nascent stages of the universe. An occurrence only possible due to the Big Bang. With the accumulation of such evidence, the tired light model by Zwicky was ignored and faded into obscurity. But then came the James Webb Space Telescope.
Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Now, it takes many billions of years to create a galaxy, like the Milky Way galaxy, with 100 billion stars, many billions of years old. But the James Webb Telescope has identified 6 galaxies that exist half a billion years after the Big Bang, that are up to 10 times bigger than the Milky Way galaxy. That shouldn't happen.
And here is where the forgotten tired light model by Fritz Zwicky returns. Theoretical physicist Rajendra Gupta from the University of Ottawa has proposed a new theory. While the tired light model does not explain the observations, Gupta combined it with a new model called co-varying coupling constant, or CCC. This model is dependent upon 3 constants, namely the speed of light, Planck constant and the gravitational constant. They are believed to undergo variations that extend the timeline of the universe by not being constant. While they do not act as the solution to all the problems created by the discoveries done by the JWST, they bring a new approach different from the LCDM model. According to the CCC plus TL model, at the redshift of 10, the universe is 5.8 billion years old, and at the redshift of 20, the universe is 3.5 billion years old. hence, giving enough time for stars and galaxies to form in regards to the image delivered by JWST. And if the universe is aged according to this model, its age sums up to 26.7 billion years, which changes the previous calculation by a huge margin. But there are loopholes in this newly proposed model of cosmology. The primary being, the constants don't seem to affect the experiments on Earth. So we are close to finding the solution, but aren't there yet. And with the way JWST is making discoveries, we might have to find the answer very soon. It will be interesting to see which model will the current and future observations that different space telescopes will bring in. Which one are you rooting for? Drop in your comments below, and don't forget to subscribe to Lab 360, because together, we will explore.